Around 2 million years ago, an ice age began in the southern hemisphere simultaneously in South America, Southern Africa, Australia, and here in New Zealand. The same thing was happening in the northern hemisphere in North America, Europe, and Asia. Indeed, in both hemispheres, the phases of the Ice Age were very similar. And so were the changes the ice brought to the look of the landscape. Like many other spots on Earth, the Ice Age, in a way, still carries on here. These are the peaks at the head of New Zealand's Franz Josef Glacier. They're 3,000 metres high, and temperatures are below zero all year round. The mountains are battered by blizzards surging in from the ocean. At this height, year after year, a huge supply of snow piles up on top of the glacier. As it thickens, this fresh snow is compressed under its own weight into ice that will eventually become part of the glacier that's underneath. It's the snow on top that feeds the ice beneath the surface.
It's in winter that the, if you like, fuel tanks of the glacier really begin to build up. It's the 4th of June and there have been 3 major snowfalls already. Let's see how much. That's about 3 meters in the first month of winter.
It may seem unbelievable, but this massive weight of frozen material actually moves downhill. When this force is directed at a single valley, like in the Franz Josef Glacier, the results are spectacular. The ice grinds away at the land rather like a huge chisel, deepening the valley, plucking rocks from the valley sides and from the valley floor. This material caught up in the ice is known as moraine. The moraine, in turn, adds to the glacier's power to erode, deepen its valley and shift stuff along.
It's amazing to see just how much material the glacier is actually carrying. In fact, it's working like a kind of giant conveyor belt. 60 years ago, it conveyed an aeroplane. It crashed 14 kilometers up the glacier and had reappeared from the end 6 years later. The largest natural item being transported by the glacier at the moment came from this huge rock face. For many years, the ice has been plucking fragments from it and shifting them 200 meters downhill, forming this huge moraine right in the middle of the glacier. It looks almost as though the piles have been dumped here by a bulldozer. Not true. It was the driving force of one of the steepest glaciers in the world, the Franz Josef.
At the height of the Ice Age, the Franz Josef was moving downhill at the incredible speed of 6 kilometers a year. The glacier's speed and its length both change according to how heavy the snowfall is on the fuel tanks at the top. It's currently 23 kilometers from the top to what is known as the snout, the spot at which so much ice is melting that the glacier can't carry on any further. Here, water joins the ice as a driving force as the glacier begins to lose its grip on all the material it's gouged out and brought downhill. Big boulders that have been moved a long way by the ice are known as erratics.
And if you need any more proof of just how powerful a glacier can be in terms of eroding rocks and transporting them, then just take a look at this one.
The land downstream from the snout is made up of layer upon layer of glacial drift. Drift being the name of all the different kinds of material shifted by the ice and the meltwater. 90% of the drift below the Franz Josef Glacier came from a rock with the weird name of greywacke. There's so much of it that it has a landscape all of its own that extends for 25 kilometers beyond the snout of the glacier. Everything here, the plains, the hills, in fact all the relief features are made of glacial drift, all the way to the beach.
But the beach isn't the end of the story, because the drift extends 10 kilometers to the west, out onto the seabed. That's how far the ice reached during its maximum extent, at the peak of the Ice Age.
Typical of New Zealand's South Island, what we've got here is a coastline made of glacial drift and all the physical geography that comes with it.
My favourite erratic in the cliffs is just up there. And I reckon with a couple more storms from the Tasman Sea, it'll be on the beach. Now the rock looks like grey wacky, but I can't be sure. But what is absolutely certain is that it can only have come from one place, the New Zealand Alps.
Throughout the world, the most spectacular effects of glaciation were felt in mountain areas. When the ice emerged into the lowlands, it still covered huge areas of the Earth's surface for around 2 million years. As the climate warmed up and the ice melted, it left behind thick deposits of material that it had picked up along its course, known as drift. In places, the drift is divided into two different types. The first is boulder clay, a sort of thick sludge that was beneath the ice. The second is outwash, a much more stony, gravelly stuff that was carried away by streams flowing from the edge of the ice sheet. Over half the UK lowlands are covered in drift. Near the Norfolk coast, it's particularly thick. Ice disappeared from here 2 million years ago, leaving behind large areas of boulder clay and outwash. 2 million years is quite a long time by the standards of the Ice Age. So in places like Norfolk, it's often not so easy to work out what the ice was actually doing. But here, however, the geologists are sure that something rather special happened.
The line of this hill marks the spot where the ice actually came to rest. It came in from the north, from that direction, and stopped right here. So, beneath the ice, over here, boulder clay was being deposited, which has given rise to land that is perfect for farming. It's what a farmer today would recognise as being good stuff. But what about the landscape over there, beyond the ice, on the outwash?
Well, there's a big contrast. The vegetation is heathland, the soil thin and no good for farming.
Two different kinds of landscape, right next to each other, all thanks to the Ice Age.
In the lowlands, the changes that ice brought to the landscape are nothing like as dramatic as those in the uplands. But in places, the lowlands can often come up with the unexpected.
Like here, on the northern coast of Norfolk. For 20 kilometres to the east and west of here, the cliffs are composed entirely of glacial drift. Not rocks that are local to the area, but stuff that was brought here from somewhere else, by the ice.
If you're into glaciation, these cliffs near the town of Cromer are one of the most famous spots in Europe. It's a 50-metre high slice through several layers of drift carried here by various ice sheets over a period of 1 million years. It's a fascinating insight into the rocks picked up along its course and the unusual landforms that have developed from this strange concoction of material. The cobbles on the beach have been eroded from the cliffs by the sea. They're the best clues as to where the ice came from.
They've all been brought from the north of here by various glacial advances. This one's chalk. It won't have come too far, and it's definitely English. From its colour, this one seems to have a high iron content, but I'm not really sure what it is. And this is sandstone. That'll be English too. This is granite, definitely Scottish, and this is marble, almost undoubtedly from southern Norway, 1,000 kilometres away. What we've got here is a multicoloured Ice Age beach.
One of the last events in Britain's Ice Age was a re-advance about 15,000 years ago of small ice sheets in mountainous areas like the Highlands of Scotland. In many places, the ice wasn't thick enough to smother the mountain range that runs like a barrier through the northwest of the country. In some spots, though, a tongue of ice did manage to force a way across. When the ice retreated 10,000 years ago, what was left behind was the usual U-shaped glacial trough. It's called a breach. There are lots of them in Scotland, and they've proved absolutely ideal as a way for railways to find a nice flat route through the mountains.